Well, hello there. This is William Hadala, and welcome to another episode of the Watt Hour. I am extremely excited to have my dear friend from the last, I think we've known each other going on to almost 8 years, and this is Steve Pignato. Steve and I have known each other back, to the TMG days, and your team at 3M supported our immersion data center work with Novec and various foreigners, and now you're with Standard Fluids, and you've taken dielectric fluids to the next level, tackling not only HPC and data centers, but also battery cells, EV packs, and storage systems, which is why we at American Lithium Energy are so excited to promote what you're all doing. So I'm excited to dive into that evolution and your transition. So you came to Standard Fluids, Steve, after your time with 3M. What was the catalyst for that shift, and what's the vision behind Standard Fluids?
Okay. Good morning, William. Nice to see you. Yes, we've known each other for since 2017. It was about when we introduced ourselves and launched into TMG Core. And was at 3M for 33 years, and really the catalyst of the whole thing with Standard Fluids was the fact that 3M decided that they were going to get out of the PFAS business, the fluorinated liquids, and all of the materials considered forever chemicals. So 3M decided that on December 20th, 2022. And honestly, it's funny because it's everyone that I work with everybody remembers the date because it's Christmas time. I walk downstairs, I get on my computer, and the first thing I see is an email from Mike Roman, the 3M CEO, basically telling us that the fluorinated business at 3M is gone, is dead. And it wasn't maybe a month and a half, and 95% of the people from the division were laid off. So they moved fast. I maintained at 3M for a year and a half because I had semiconductor experience, and 3M has various other products in the semiconductor portfolio. So I stayed at 3M, and the folks that started 3M, there's three. It's Paul Rivers, Luis Gonzalez, and Rory Quirk. They decided that because Lewis and Paul and Rory, they're all in the fire protection business, they decided that they would start this business called Standard Fluids and support the fire protection business because that's what their background was. And they started to talk to me in the summertime of 2023 and saying, "Hey, Steve, we want to use or work with you on the engineered fluids. Really the engineered fluids are the chemicals that 3M really shouldn't have gotten out of. They are sustainable, and we can get into the environmental profiles and the toxicity profiles and all that stuff. But really, they were the sustainable molecules that 3M was making, and that when I was in the laboratory in 1992, I was in the lab for 4 years while I was getting my chemical engineering degree, and that's when the HFEs, the hydrofluoroethers, were developed at 3M. And again, very sustainable. And I won't get into them because you asked me about Standard Fluids, but there's a really deep dive on the chemistry of the HFEs. It's very important. But so Standard Fluids was asking me to join, and because it was a startup, they had to get their stuff going and the ball rolling with the company. And I talked to them, worked with them a little bit through the rest of 2023, and then I joined April 1st of 2024. I had enough of being at 3M at the time, and decided that working with these gentlemen to help them with the business was a good idea. So that's really the start of Standard Fluids. And, Standard Fluids is handling all of the chemistry that 3M really shouldn't have got out of the sustainable. They are PFAS. And now we don't need to get into it here, but, a lot of the chemical companies and other companies out there that say, "Oh, we're not a PFAS. We're not a PFAS." It's like, yeah.
If you had to sum up these dielectric fluids, which I've been describing for people for years, whether they think it's this dream or reality, how do you sum that up for somebody that may not understand what these dielectrics are and the importance of what they can do, not only in high capacity compute, think data centers, but also in the battery storage world?
That's a good question. And honestly, if you think about it, these chemicals go all the way back to the 1930s and 40s. So, they were developed for the Manhattan Project. There's a gentleman by the name of Joseph Simon from Penn State University who developed the process for making perfluorocarbon liquids, PFCs. And that was started in the 1930s. It was used in the Manhattan Project for uranium hexafluoride separation. It was a cooling media that would not react with uranium. And it was used pretty much all the way through the Manhattan Project and beyond. And 3M must have picked up the technology somehow in the 1940s and 50s. They must have been working with him or with the project somehow, because 3M was making PFC liquids for many years, I would say starting in the 40s. And what the fluids were used for was immersion cooling of electronics, of radar klystrons, radar arrays, the electronics. The dielectric strength and the resistivity of these fluids, because they are totally fluorinated. I mean, you can drop your phone, your computer, your television, any electronic inside these fluids, and that it will not short them out. There's no conductivity path, so you basically can almost go in there and touch the electronics, right? So it's very safe in that regard, and it's been used for electronics cooling since the beginning, right? And then the history is really, really rich, but in the 1960s, 1969, IBM actually used the fluorinert to cool a chip. It was the bipolar architecture, and they cooled the chip with FC72. And then IBM went on to use the fluorinert for multi-chip module testing in Poughkeepsie, New York, for their data or for their computers. And that continued on with Cray Research. So Cray Research then started to use the fluorinert after they tried Freon 113, which there's complications with Freon that we won't get into, obviously. But the ozone depletion was number one.
Right, yeah.
The compatibility with the electronics and the compute was the other, right? So, they started out with the Freon 113, but very quickly realized that everything they put into it started to dissolve and had issues with the Freon. So, Cray Research then moved on to the fluorinert. And so fluorinert's been really important on the electronic side. It's used very extensively in the military for cooling components that are on F-18s and F-16s and F-15, all sorts of military equipment. That's not sensitive information. It's out there on the internet. So it's just really, a very, very interesting fluid. And it has its niche in the world, right, for electronics cooling. And we have moved forward with battery cooling. There have been some companies in the past that have used really the Novec brand. The interesting part of the HFEs, the hydrofluoroethers, is they were developed in the early 90s because of the Freon issues, the CFC issues with ozone depletion. Companies were using the fluorinert to replace the Freon, but then they were saying, well, the fluorinert is good and fine. It doesn't break down the ozone, but it doesn't do anything. And the global warming potential is in the thousands, 10,000 plus, right? So fluorinert had its issue with global warming potential. And 3M realized that right away, honestly, and developed these great hydrofluoroether molecules. I got to work with them in the very beginning. It was really, really neat working with the scientists at 3M when they were developing these products. So back to battery and and electronics cooling, fast forward to today, we do have applications where these molecules can be in direct contact in the battery cells and, in cooling the batteries. And also there's a really neat application for batteries for thermal runaway. So it's able to stop the thermal runaway. And, there's a lot of, I guess a lot of testing has been done, but because of 3M's exit from the business, it kind of slowed down. But I think that Standard Fluids, William, we've been talking to you guys about looking at the perfluoroketones for thermal runaway. So that's
And it's really important because, like, as a battery cell manufacturer with SafeCore, that prevents the three most common reasons cell go into thermal runaway, which are internal shorts, overcharging, and temperature. That's at the cell level. So to build intrinsic safety at the pack level with these fluids is a game changer. And going back to 2016 to 2018, what was really interesting was being part of a team that was looking to design and build data centers or buy and lease back. For me at that time, it was about building these small rural data centers across rural America to help with these utilities and their automation and public safety. And I couldn't make at that time the financials work until we looked at cryptocurrency and cryptocurrency mining. And then it was like, well, maybe cryptocurrency mining could offset the cost of the data center. And before you know it, TMG Core was birthed. And then we sort of pivoted from crypto to high capacity compute at the edge. So my question to you on that is, let's revisit immersion cooling and high performance compute in crypto. What do you see are the leading trends today, and how do Standard Fluids products stack up?
Okay, excellent question. So the trends today for cooling of data centers, right? There was a big push. So it's a difficult question. It's a great question, but there's a lot of twists and turns. So when we were talking to TMG Core in 2017 and yourself, and there are a lot of things online with Intel or Microsoft where the total immersion, two-phase total immersion, what really was developed, at IBM in 1969, but really a gentleman by the name of Phil Tuma from 3M really kind of had the sight to look at some of the stuff we were doing at 3M with, and you're going to die with it, but degreasers. And the fact that you could have a degreaser to some boiling all day long and putting parts in and out, and you wouldn't really lose any fluid because of the design of the machine that kept the fluid in the tank. So he really started with that concept and worked with a couple of companies, Endicott Interconnect, Mayo Clinic, again, really well-known information out there, to do the total immersion two-phase approach, which was different from Cray Research, which was doing just single phase. And single phase cooling, it doesn't have the heat capacity, right? Like, cause you're doing, you're just using the liquid phase. You're not changing phase like in a two-phase system, right? So you have better thermal performance with phase change. And so the data center immersion cooling at 3M anyway was started around 2010. And what you had said about crypto was really important, because what we were having problems with was HPC and normal data center companies looking at the technology and going, yeah, it's great, it's good and fine, but there's really no information on it, and everything's designed for air cooling, so we're a long ways away. So what was kind of fortuitous was that a company called Allied Control was starting up in Hong Kong, and this was about 2012. And they really did design a two-phase immersion cooling system with Phil Tuma and with George Ip from 3M. And the gentleman that's still at Liquid Stack today is Car Wing-Lao. And I have a picture of all of them in Hong Kong with bags from the hardware store, right? It's really funny. So they really did start up the two-phase immersion cooling with crypto. And it was easier to start with crypto because the boards were easily immersed or submerged in the fluid, and you didn't need boiling enhancement coatings because the chips were relatively low power. So it was a really, really good fit. And Allied Control really moved forward through the 2012 to 2016, 17 area time frame where they were building data centers even with crypto. So they really helped get that technology up and running. And then about 2017, and I don't know, some of this gets to be a little bit confidential, so I gotta watch what I say, but Microsoft was really, really open about the work that they were doing in immersion cooling, two-phase immersion cooling with 3M. So there's, OCP papers, OCP presentations, a lot
Open
of good,
compute platform for our viewers,
yeah.
OCP, right? Standardization of equipment from the server
Correct.
to the storage
Yeah.
to the rack, so anyone could provide services to a hyperscaler like Microsoft.
Perfect. Yes. Perfect. So we were working in that area with Microsoft, and really, once 3M decided to get out of the fluid, that whole program died. So, two-phase immersion cooling in the HPC and the data center market really took a step backwards. But Standard Fluids, myself, and many other companies now are really pushing towards the total immersion two-phase, because you asked me about the trends, and the trends today, and for various reasons, but the trends today are to go to direct to chip cold plate cooling, right? Which IBM started in the 1997. I think the P7IH was the name of the computer, and they were just bringing water right to the hot chips, right? But the thing with the IBM servers, they only had two big giant chips that they were cooling, so it was pretty simple. But now they are looking at the rack formation with direct-to-chip cooling or cold plate cooling, you can call it either way. But there's still airflow needed. There's a lot of hardware. It's very hardware intense.
It's very
And really,
complex. It's like bringing plumbing systems into a data center at the rack level, but go on.
yeah. Yeah, and it's just really it's doing okay. It is the trend today, but I think even Microsoft just put out a paper a couple of months ago where they said really the future still needs to be two-phase immersion cooling,
There was
because
a
it
nice
just
flow chart I remember that they had where it showed air cool, rear door heat exchange, liquid on chip, single phase, and two phase, published by Microsoft. But go on.
yeah, correct. And they're we won't delve too much into Microsoft, but like Standard Fluids, we're working with the chemistry is the C6 ketone, and it's the SF649, which was the Novec 649. And it really, is a very good molecule because it has all of the perks of the fluorinert, which is, stability, and there's a lot of discussion there on the stability because there were issues with it in the very beginning, but the engineers and the scientists, especially at 3M, even at Microsoft, that worked with the C6 ketone really were able to get the molecule working where, once you had the system designed correctly to handle the C6 ketone, systems were running for years without any issues.
So let me jump in on that. There's a good follow-up question on that, is that, when you think about GWP, which you can explain what that means to our viewers, but the SF649 is sometimes called the ideal Novec replacement because it offers single-phase route with ultra-low GWP. And you just mentioned that. Walk us through the key thermal properties and what sets this fluid apart.
Really the key thermal properties, and the thing is when you compare thermal properties of water to a perfluorocarbon or a fluorinated liquid, that's it's like a quarter of that of water. So, but what you can do is you can put the electronics right in contact with the fluid, right? So the dielectric strength of these fluids is very high. And you can submerge the fluid of the components and the electronics right into the fluid. So there's a thing called thermal resistance, and you basically have a path of the heat coming off of the chip. And when you're doing cold plate, you have multiple resistances in the flow of the heat coming off the chip. So it suffers a little bit in that regard. And then when you have a two-phase immersion fluid, it's in direct contact with that chip. So there's less resistances from the heat to get out. So it's very, so many papers, so many people have done so much work on each one of these technologies. So, what's going to win out in the end? I don't, I know it's going to be two-phase immersion cooling, but how and when is the question at this point.
It really is, and that GWP standing for global warming potential.
Yeah, sorry,
so we put that up there.
So, yeah.
I remember back in the day with TMG that with single phase versus two phases, single phase has traditionally been like mineral type oils, and from a burning in of servers, meaning you order a server from a Dell or an HPE, they've got to burn that server in, and burning in servers at a factory with single phase offers a lot of complexity, whereas with two phase, it's a very clean procedure. In fact, the boards will probably come back much cleaner than they were before.
Yeah.
So jumping into battery and EV immersion cooling, you've expanded into this thermal management piece for lithium ion cells, packs, and storage. For me and our viewers, why dielectric fluids?
Really just because of non-flammability, right? So, in the possibility that you do have thermal runaway, and in the system using hydrocarbons is a difficult thing because now you have more material that's going to be on fire, right? Or starting on fire. So non-flammability is major, but also, using the PFCs or the ketones, it's actually going to put the fire out. So thermal management wise, it's working. It carries the heat out just like any other, thermal liquid will, but you have that extra layer of protection because it'll stop the thermal runaway, right? Or it'll stop fires. So I think that's probably the best answer.
Yeah, well, no. You've got a presentation that you'll share with others under NDA, but the question is, where it has this amazing performance and safety benefits in EV application, especially at the cell level. Can you talk a little bit about that?
I really don't have the knowledge in that area other than it's non-reactive, right? Like the at the cell level, it's not in direct contact with the lithium ion cell. It's more still a cold plate application, right? So I think that's the best I can explain on that. I apologize for that.
No. And just to follow up on that, bringing a little bit of batteries, chemistry, and science is that, in an air-cooled situation with cells next to each other, call them a bunch of 18650s. If you throw one of those cells in the thermal runaway, there'll be a trigger reaction where the cells next to it will trigger, then trigger, then trigger. Whereas the experimentation that we've seen with your fluids is if you put that on a pack level, even though you may throw that 18650 into thermal runaway, it will not trigger a reaction across the other cells in the pack. And doing it with a very little amount of fluid, so there's really not a huge weight impact.
Correct. Yes, and that what you said is absolutely correct. So it's under development. So who gets to the market first with that is really kind of important at this point.
Some of the surprises for new adopters when using this fluid for the first time. Why is it so important to work with perhaps a tank provider trying to do this on your own?
Well, yes, just because there is some engineering needed, right? And the tank providers, so now we're up to about 8 or 9 of them here that have the knowledge for handling the fluid. And the first thing first is the fluid's expensive. So you want to keep it in the tank. So simple design stuff, and I know that we had conversations with this like this at TMG Core, but a little bit of freeboard above the condensers goes a long ways. And that's knowledge from the old vapor degreasing days. But the problem was in the beginning when we were working with you guys at TMG Core is we were doing 36-inch long Dell 4140s or something, you know what I mean? So now you need 36 inches of fluid for, maybe 2 kilowatt board, which was absolutely horrific. And that's so the tank design with the cost of the fluid and the technical knowledge that you need for keeping the fluid in the tank, right? So it all kind of goes together in a nice little recipe that, myself, Phil Tuma, we worked on for so long, and we gave the knowledge. We worked with TMG Core and with Ally Control, which was now Liquid Stack. And now there's a handful of others that all kind of spawned from TMG Core. And that knowledge is out there now. So the tank builders are designing systems that can handle the fluid, and going to a more dense or higher density compute is very, very important, right? For these fluids, because imagine using a fluid that's, whatever, $50 a liter, and for a huge Dell 4140 or whatever their highest power big server that's air cooled, and they're putting it into this fluid, you might need 30 liters of fluid. So 30 liters of fluid to cool 2 kilowatts is ridiculous. So what we were doing, and especially in crypto, the boards were very tight, very close, and the fluid could definitely do that cooling. And so where we're headed in the future is higher density, lower fluid use, and the tank designs that can handle the fluid. Because there's other aspects of the fluid that you need to take care of in the process. Okay.
Yeah, and what I love about the future, at least for somebody like me, selfishly now with American Lithium Energy, a 20-year-old lithium-ion battery manufacturer, is the ability to put the compute and the energy storage into an edge type of environment where the economics do make sense. So as we do this lightning round here, for you, single phase or two phase, what's your go-to?
For me, two phase, 100%.
And what is the biggest myth about fluid immersion?
That it's expensive.
Okay, and what's one piece of advice for engineers exploring immersion cooling?
Make sure you talk to the right OEMs.
And as we close here, Steve, for engineers or facility operators considering dielectric immersion in data centers or in battery packs, where should they start?
At Standard Fluids. So honestly, right? Yes. I mean, looking in, so start talking to us. Contact us at Standard Fluids, and we'll be able to walk you through all the technologies and the fluids and what to do and what not to do, I guess.
And if it wasn't for Steve and Phil Tuma, many could say that TMG Core may have never been a reality. As I remember getting that phone call asking me, what do I know about two-phase liquid immersion or dielectrics? And at that time I said nothing, but within an hour I had Steve and Phil on a line. We flew you down, and the rest is history. So for our viewers, how can they engage with Standard Fluids, like samples, pilots, custom R&D support?
So yes, custom R&D support. We have engineered services. So myself, there's, the rest of the team, like John Owens, Paul Rivers, Conrad Kaminsky just came on board. We're all engineers. We've worked with the fluids for 30 plus years, even 40 years. John Owens was at 39 years. So, engineering support, and we obviously can get samples, and we also can get you contacts to the right ecosystem players in a data center world, right? So, the Amphenols and the Vertivs and the folks that are going to put all the bits and pieces into a data center, they all have been on board with two-phase immersion cooling for the most part, until 3M decided. But yes, working with us on that, we can get you the right contacts, we can get you the fluid and engineering support, 100%.
And before we wrap, do you have anything exciting coming that we should think about or flag before we wrap?
No, I would say the most exciting stuff is in the data center world. There's a partner that we're working with called Magnalytics that is helping, and it's Magnalytics with so Magnalytyx, I think. Magnalytics, I think it's so. They're part of Kaizen, and they honestly have done a great job with a new system that will be presented at OCP this year, the Open Compute Project, right? In October in San Jose. And they are presenting the device and the technology that they created to monitor the health of the fluid, because that's been one of the big sticking points for two-phase immersion cooling. So they are able to make sure that the system is healthy and that it's almost hands-off, right? Because that's, what are we going to do with the fluid when we need to change a board? Who needs to go in there? Blah, so there's a lot of those questions that this new technology will be able to solve. So that'll be exciting. And then on the battery side of things, there is a higher boiling product that Standard Fluids has that will be able to shut down the thermal runaway quicker with less fluid. So, always making, improvements on the process or on the application. So,
Steve Pignato, Standard Fluids, you've been a good friend. Thank you so much for taking the time to do this interview with us.
You're welcome, William. It's good to see you. Thank you very much for inviting me.
You're welcome. Thank you, sir.
Yep.